Hello, this is Brianna, and today I'm going to be covering questions 1 and 2, questions 1 and 3 on our mock final exam. So for question number 1, it asks us to find the volume of the solid generated by revolving the region bounded by the curves f of x is equal to the square root of x, and g of x is equal to x squared. Now, in order to find where these points intersect, we're going to set them equal to each other. So root of x is equal to x squared. And when we plug in 0 on this, when we plug in 0 for x, we get the same answer on both sides, 0. And also when we plug in 1 for x on both sides, we get 1 on both sides. So we know our points of intersection are at x is equal to 0 and that x is equal to 1. Get that out of the way. Right? Cool. So let's just graph that real quick. And let's remember that they're going to be rotated about the y is equal to 1 line, which is this line right here. Okay, so for f of x, we're going to use this color. So this, when we graph it, it's going to look like that, right? It's the parabola on its side, right? So when we're just drawing this section of it, let's do our other one. Okay. So it's going to intersect at this point, 1, 1. This one, oops, when x is equal to 1, our y is equal to, we'll see that blue line there, it's okay. I don't think it's too confusing. All right. And then for our x squared, which is our g of x line, it is a parabola going up like this. So we're just drawing this cross section of it. Because yeah, sorry, because this is our cross section, these are our points of intersection, right? They intersect here and at here. Right, we can draw another line, dot here where they intersect. All right. Now, when we rotate it around this axis, it's going to flip. And it will look like this. Oh, sorry. Here. And here. This line is supposed to be curved, by the way. I'm just not the best drawer. All right. Now you can see here that while this end does touch, it is actually hollow in the middle, right? Because they're not touching here. So it's just touching at that one point. All right. So let's get a new color. Let's do green. Green will stand out well. All right. So as you can see here, once we draw in our rectangles, it's pretty clear that we're going to be using the washer method in order to solve for volume. Right? Now, in order to find the values for the washer method, we have to take the pi r squared of the outer radius and then pi r squared of with the inner radius, right? So in order to find our outer and inner radius, let's define a few things. the area under this curve here is our outer radius. You see how it hits the bottom of here, right? And this, since it's under this curve, it is going to be equal to x squared. And you see how our inner radius hits here? So anything under this curve is equal to our square root of x. And then this is equal to 1, right? So you see our outer radius is 1. And then this has this extra value, so it's going to be 1 minus x squared, right? So radius outer is equal to 1 minus x squared. And then our inner is equal to 1 minus this here, right? This area under this curve, which is just going to be 1 minus root x. Okay. Now that we've defined these, we can use our volume equation. So our volume is equal to the integral of a to b by pi times r squared minus pi times the inner radius squared. And it's going to intersect to x, dx. So we can pull the pi out because both of our terms have it. Just to simplify things a little bit, our a is 0 and our b is 1. Then we can plug in our outer radius, which is 1 minus x squared, minus our inner radius, which, sorry, I did not put the squared. And then minus our inner radius squared, which is 1 minus the square root of x squared. Sorry about my dogs in the background. Okay. I'm going to scroll up a little bit. Hope you guys were able to see that. Now you can always go back and play the video if you're able to copy this down if you're writing it. Okay. Now, for the next step to simplify this, we are just going to FOIL these out, these terms out. So that is going to be our volume is equal to pi times the integral from 0 to 1 of x squared times x squared is x to the 4th, and then we're going to have I just wrote x squared. Negative x squared times negative x squared is x to the 4th. Negative x squared times 1 plus negative x squared times 1 is equal to negative 2x squared. And then we're going to have 1 times 1, which is going to be plus 1. And then we're going to subtract this from the radix. Square root of x times the square root of x gives us just x. And then negative square root of x times 1 plus the negative square root of x times 1 is just going to be minus 2 rad x, square root x, plus 1. 1 times 1 is 1. Cool. Dx. Sick. All right. Volume is equal to pi by the integral from 0 to 1. So we can just multiply this minus sign through and recognize that these ones will cancel, and that will give us x to the 4th minus 2x squared. Then we're going to get minus x, and then plus 2. And if we want, we can actually rewrite this. My brain just likes this better for integrating, because now we're at the point where we can integrate. Excuse me. Okay, so our volume is equal to pi by the integral from 0 to 1. Oh, sorry. We're integrating. We don't need that anymore. We did that. right, so x to the fifth over 5 minus 2x to the third over 3 minus x squared over 2 plus, and so 2 divided by 3/4, which is going to give us 2 divided by 3/4, keep change flip, is going to be 2 by 2 divided by 3, which is going to be 4 over 3 x to the 3 halves. And then, yeah, okay. That is our integral, right? And remember that this is a definite integral, and we're doing it from 0 to 1. Oh, not mean to do that. Okay. Now we can plug in where integrals defined at. So we got pi times 1 to the fifth over 5 minus 2, 1 cubed over 3 minus 1 squared over 2, 5 plus 4 by 1 to the 3 halves over 3. Now keep in mind every single one of these terms has x, so no matter what you multiply 0 times, it's going to be 0. So all these terms is just going to be 0 over a value. So this just all equals 0, right? It's this entire side of it. When we plug in 0 for the second half of it, it's all just going to be equal to 0. So for time's sake, I'm just going to write it like that. Now, all these are just going to turn into, oh wait, sorry. I'll rewrite it just so it's a little easier to follow. So we're going to have 1/5 minus 2/3 minus 1/2 plus 4/3, right? Okay, now when we plug this into our calculator and, we add and subtract the fractions properly and then multiply it times pi, we get that the volume is equal to 11 pi over 30. Okay, and that is our solution. And again, this is for problem 1 on our practice final exam. Let me just zoom out a little bit again so you can see that all. All right, so that is our entire solution, right? And we solved for this right here. Okay, now I'm going to erase this. And reset our Zoom. Right, cool. Now let's take a peek at problem number 3 from our practice final exam. Question number 3 asks us to find the center of mass of the lambda of the uniform density, and density is equal to 1, bounded by the graph of f of x is equal to 4 minus x squared and the x-axis. So this is our given information. Density is equal to 1. F of x is equal to 4 minus x squared. And we are bounded by the x-axis. In order to find our center of mass, we first have to find our moment of x and our moment of y. Now, keep in mind, those are integration problems, as mx is equal to our density times the integral from a to b by half of f of x squared, and our my is equal to our density times the integral from a to b of x times f of x. Nope, that does not look like an f of x. F of x. Okay? And both these are in respect to x. Now, in order to get our a to b, right, that is our interval. So here, our bounds are defined by the x-axis, right? When something is at our x-axis, that means our y value is going to be equal to 0, right? So that means we consider f of x equal to 0. So when we have 0 is equal to 4 minus x squared, that turns into x is equal to 4, or sorry, x squared is equal to 4, right? Because this is going to turn to minus 4, multiply minus sign through, then you're going to get plus for both values. All right, and then this, we're going to take the square root of 4, right? Let's do it in green just so we can see what we're doing, right? So that means x is going to be equal to plus or minus 2. So this is our points of intersection, right? So minus 2 is going to be our A and plus 2 is going to be our B. Now that we've defined those, let's find our mx. Let's do mx first, right? So mx is equal to density, our density is equal to 1 times the integral from a to b, sorry, excuse me, a to b, which is our negative 2 to 2, times half of our f of x squared. Our f of x is equal to 4 minus x squared with respect to dx. Now, let's just, since our 1/2 is our constant, we can just multiply it by our 1 that is in the front. So we're going to get 1/2 by the integral from negative 2 to 2 of 4 minus x squared. Oh, I did not put the squared sign out here. Now, we can FOIL this out. So we're going to get half negative 2 to 2, and that is going to get us x to the 4th minus, it's going to be negative 2x times 4 plus negative 2x times 4. So it's going to be negative 8x squared. And then 4 times 4 is 16 plus 16 dx. Now this is simplified enough where we can easily integrate. So we have our mx is equal to half of x to the 5th over 5 minus 8x to the 3rd over 3 plus 16x. Remember, it's a different integral from negative 2 to 2. So, actually, let's give this a little more space. Let's just scroll down. Cool. So our mx is equal to half of 2 to the 5th over 5 minus 8 to 2, 3 plus 16 by 2 minus -2 to the 5th over 5 minus 8 times 2 cubed over 3. Oh, got the negative sign there. And I import it. Plus 16 times -2. Oh, I'm not gonna do that. All right. So that means mx is equal to half of sorry. I did not mean to do that. Great. So 2 to the 5th is 32 over 5 minus 2 to the 3rd times 8 is equal to 64 times 3 plus 16 times 2 is 32 minus negative 32 over 5 plus 64 over 3 minus 32. Now, I could like actually solve this out or use a little bit of logic or cut here. So as we can see, this term is opposite of this, but is multiplied by a minus sign, right? So this term is actually just going to be these same numbers added to each other, right? So it's going to be 32 over 5 plus 32 over 5, negative 64 over 3 minus 64 over 3, and then 32 plus 32, right? So these values are going to be doubled, correct? So that means since it's going to be doubled, and then we're going to take half of it, instead of doing that, we could just cross out this, and our answer is going to be equal to this first term here. Oops. What's wrong with my laptop? We'll make it. I might have to pause the recording for a second. When we add these together, we get so sorry, that our mx is equal to, sorry, I have this in a decimal because that's what my calculator gave me earlier, but let me give us a nice fraction to work with. I'm just plugging into my calculator real quick. So it is going to be plus 32. So it is going to be 256 over 50. Cool. I'm going to pause the recording real quick. And then okay, I just paused it and I came back. Hopefully nothing got messed up. My apologies if something did. I have to grab my laptop charger real quick. All right, so now that we found our mx, we can find our my. Remember we showed what that equation was right there. If you need to see it again, you can scroll back up to the top, but I'll explain it. So it is going to be our density, which is equal to 1 by the integral of a to b, which is our -2 to 2, right? And then it's going to be x times f of x. So it is going to be x times 4 minus x squared, right? dx. Never forget the dx. So we're just going to multiply that x through. So this is going to be equal to, and this is just times 1 for density, so we don't have to keep writing that, right? -2, 2, And then x times 4 is going to be 4x minus x times x squared is x to the third dx. Right, so this is a pretty simple integration problem. So this is going to turn into 4x squared divided by 2, which is equivalent to 2x squared minus x to the fourth over 4. Okay, over 4. Oh, yeah. And then remember, this is a definite integral from -2 to 2. All right. So now let's solve the definite integral. So it is going to be 2 times 2 squared minus 2 to the fourth over 4 minus 2 to the -2 squared minus -2 to the fourth over 4. Yeah. Okay. Now, you might be noticing something. We only have even powers, meaning that these are going to be equivalent to each other. So when you have the same thing minus the same thing, it is going to be equal to 0. But I'll just simplify this a bit so it's a little bit more obvious before I just go and scribble down 0. So 2 times 2 squared is equal to 8 minus, and then 2 to the fourth divided by 4 is equal to 4. Because 2 to the fourth is 16. 16 divided by 4 is 4. So minus, and then that's going to be the same thing. So 2 times 2 squared is 8, and then minus -2 to the fourth over 4 is going to be 4. So this is going to be equal to 8 minus 4 is 4. 8 minus 4 is 4. We'll play that negative sign through. 4 minus 4 equal to 0. All right, so that is our my. Now, we are trying to find center of mass, right? That's our end goal. And our equations is x bar, right? This is our x value or x coordinate for where the center of mass is equal to my over m, and our y bar is equal to mx over m. Now you might be wondering what our m is. The lowercase m value is mass. Now, never taken physics before. We're gonna have to do a little simple equation, as often used in physics. So density, right, is equal to mass over volume. Now, if we manipulate this equation, we can get what mass is equal to. And mass is equal to density times volume. Right? Seems pretty simple, pretty straightforward. Because we do know our density value, it's just 1. And we do know how to solve for volume in calculus. How do we solve for volume in calculus? Well, volume is just the integral for f of x, right? So we have density, which is just 1, times the integral from a to b. Remember, a is -2 and our b is +2 of f of x, which is just going to be 4 minus x squared dx, this is going to be equal to 4x minus x to the third over 3. And this is going to equal integral from -2 to 2. Let's solve for the definite integral. So this is going to be 4 times 2 minus 2 to the third over 3 minus 4 times -2 minus 2 -2, sorry, the third over 3. So remember this is equal to m. Probably should have wrote that. So m is equal to 4 times 2, 8. Got that. 2 cubed is also 8 over 3 minus -8 over minus -8 over 3. Right? So this is equal to, when we multiply all those minus signs through whatever, this is going to be 8 plus 8 minus 8 over 3. And then plus minus, no, minus 8 over 3, which is equal to, la la la, 16 minus 16 divided by 3, right? So that is going to be equal to 32 over 3. So this is our mass. Cool. So now we've actually found all of our missing values that we need for our x bar and our y bar. So x bar, remember, it is my over our mass, moment y over our mass, and our moment of y, remember, was 0. 0 over any number is equal to 0. So that's going to be our x bar. And our y bar is equal to the moment of x, which was, sorry, we should go back up. $256 over, it's 256 over 17. So we get 256 over 17 over 32 over 3, which I was our mass, which is approximately equal, or we can do exactly equals. Sorry, I did approximate last time in this equation, but let's just do exactly. Let me double check that number. I'm paranoid. 15. I knew it. I knew it. Felt like it was wrong. Sorry. Two, 5, 6 divided by 15 divided by 32 divided by 3, which is equal to 8 bits. Cool. So that means our center of mass is located at 0,8 bits. And that is the answer. It's actually not that hard to solve for. It's just kind of a lot of work. So yeah, again, this was question number 3 from our practice final exam in Calculus 2. And that is the solution. Thank you for watching.